Hello, this is the video for Chapter 4, Lesson 2. So with this lesson, we're continuing to look at triangles. And there's two big theorems that we're going to learn. Basically, these are special qualities, characteristics of triangles. So I would take out your notes and write this down. Okay, so the first theorem that we're going to look at is called the triangle angle sum theorem. Triangle angle sum theorem. This theorem states that if I have a triangle and I add up all the angles to each other, doesn't matter what kind of triangle it is. So let's say this is angle 1, angle 2, and angle 3. If I add up all the angles to each other, it always will equal 180 degrees. So I am actually going to show you a video on YouTube, and I'm going to credit that to this teacher here. You can even go on YouTube and watch it yourself. But basically, she's going to show you how this theorem works and how it guarantees that every time you add up the angles of a triangle, it equals 180. So watch and see what she does with it.
Let's show you a little illustration involving the triangle sum theorem. The triangle sum theorem, which is sometimes called the triangle angle sum theorem because it's really about the angles in a triangle, or the triangle interior angle sum theorem because it's about the interior angles in a triangle. It's the one that says all the angles in a triangle have to add up to 180. And while I know you would probably believe that, I'm going to show it to you in a way that kind of proves it. So let me just start out by talking about a line. I drew a line here, and I just want to go first with the agreement that if I have a line that on one side of the line, like if I think of this as like an angle, or maybe this would be the vertex, one side of a line is 180 degrees. Because remember, all the way around is 360. And 180 plus 180 adds up to 360. So all of the degrees on one side of a line should add up to 180. Another way of thinking about that is a line, which is sometimes called a straight angle. We could think of it as an angle that measures 180. Okay, so assuming you believe that a line that measures 180, I have made a triangle. I drew a triangle. Doesn't matter what kind of triangle I drew. I drew one. Mine kind of ended up looking like a right triangle, but it doesn't have to. It could look like any kind of triangle. And I'm going to prove to you that these measurements add up to 180 without ever measuring any of them. Here's how I'm going to do it. First, I'm going to cut out my triangle. And you can do this with any size triangle. Okay, so here's my triangle. It has 3 angles, and again, I'm trying to prove to you that those 3 angles add up to 180. All right, so I'm going to take the angles, and actually, let me number them. I'm going to number them angle 1, angle 2, angle 3. And I'm going to tear up my triangle. I'm not mad at it. I'm just tearing these angles apart. So there's angle 1. And now let me tear apart angles 2 and 3. So I have the 3 angles of my triangle torn apart. So now I'm going to go back to that line. Remember that we said a straight line has to measure 180 degrees. So this time I drew my straight line on graph paper. Here's my straight line. And when I say straight line, really, that's kind of a weird thing to say. It doesn't have any meaning because all lines are straight. If it wasn't a straight line, we would call it a curve. But so, a straight line or a line. And if all this on one side has to add up to 180, then when I put my angles, my 3 angles I tore out of my triangle, up next to the line, with their tips touching, like that's the vertex of the angle, look what's going to happen. They're going to take up all the space on one side of the line, which means they have to all add up to 180. So
Okay, so as you guys can see from that video, you can see very visually that all the angles of a triangle, when you take them apart and put them together, it makes a straight line, which means it adds up to be 180. So using this theorem, we can actually find an angle that's missing. So in this example, we can see that two angle measurements were given to us, but we're missing this angle T. And so we know that 25 plus 35 plus angle T have to equal 180 because angle R plus angle S plus angle T, doesn't matter their measurements, must add up to be 180 degrees. Therefore, you can add them all up and work them out. Now, because we're missing one angle, like the work shown here, we would just replace angle T with maybe a variable, or here they just wrote it as measurement of T. Then you could write it as 25 plus 35 plus X or plus T equals 180. And then this is an algebraic equation you can work out. So then you would combine these, 60 plus X equals 180, and then angle T is 120 degrees. So could you not also do 180 minus 25 minus 35 and get what's left? Yes, you could. I would like for you to practice thinking through this theorem by at least showing me the equation of three of them adding up equaling to 180, because as you set up an equation like this, it also helps you remember this theorem. So I'm going to do 62 plus 90 plus angle 1 equals 180. And if when you're working this out, you want to do 180 minus 90 minus 62 and find the answer, that's fine. But I want you to at least write the equation out so that you are able to articulate with your equation the sum, meaning adding all of them, equals 180 degrees. And when you work this out, this would be 28 degrees. Put a degree sign to show it's the degree measurement. All right, number two, we've got two angles that show this little symbol, meaning they're the same. So if this is angle 30, this will also be angle 30. So now you can do 30 plus 30 plus angle 1 equals 180 degrees. And so 180 minus 60 is 120. Or you could do 180 minus 30, which is 120. So angle 1 is 120. All right, looking here, we're trying to find this angle right here, angle 1. So let's take a look at what's going on. We've been given this whole triangle, and we've also been given half of the triangle. We've got angle 1 and angle 2 that we have to find. So right here, if this is a right angle, we can also assume that the other side right here is also a right angle, because these two lines are perpendicular. So you should have two right angles here. So you can work them out two different, I guess the same way really, but we've got two equations we've got to do. Angle 2 plus angle T plus this angle right here, which is a right angle, equals 180. So I'm going to write this as angle 2 plus 90 degrees plus 30 degrees equals 180 degrees. All right, and then I can work this out, solve it, and find that angle 2 is 60 degrees. Finding angle 1 here. Angle 1 plus this green angle, 90 degrees, plus 60 equals 180. So I'm going to subtract angle 1 equals 30 degrees. So angle 1 is 30 degrees. So let's look here. Ooh, we've got a set of what we call vertical angles. Angle 1 and 2 should be the same because there's two intersecting lines. So right here, we don't have two angles. We don't have angle 2 and we don't have angle 3. So I can't solve for either one of those unless I know what angle 1 is. And so if I can say, I have these two angles, because this is a triangle right here. If 66 plus 58 plus angle 1 equals 180, I can solve for angle 1, and that's 56 degrees. So angle 1 equals 56, which means if I know angle 1, then angle 2 should be the same. Angle 2 is also 56 degrees. So angle 2 here, I'm going to write as 56 degrees because they're vertical angles. That tells me that those are the same. Now I can work out to find angle 3. So basically I have angle 2, which is 56 degrees, plus 50 degrees, plus angle 3, and that equals 180 degrees. So that worked out as an algebraic equation would be 74 degrees. So angle 3 is 74 degrees. All right, over here. Now, anytime you see a right angle, you see perpendicular lines, you can assume that this angle is also a right angle, okay? So anytime you see perpendicular lines, the two angles on both sides of it should be 90 degrees. All right, so looking at this, let's solve for angle 2. We've got 30 degrees, 90 degrees, and angle 2. I can't really tell actually if this angle 2 is for the whole angle or if it's just this part right here. But regardless, we know that 1 and 2 have to add up to be 90 degrees. So let's just assume that angle 2 is this part right here. So this would be 90 plus 30 plus angle 2 equals 180. So I'm going to subtract 90 and 30 from both sides. Angle 2 equals 60 degrees. And then angle 1, to find that, we do 60 plus 90 plus angle 1 equals 180. That's very similar to number 3, doesn't it? Isn't it? So then when I subtract, angle 1 equals 30 degrees. All right, last one here, number 6. So I've got 20 degrees, 152, and 1 degrees. So I know all of them added equals 180. And so 180 minus 20 is 160. 160 minus 152 is 8. So angle 1 is 8 degrees. And that's the answer. All right, looking at the back of our study guide, we're going to learn a new theorem here. So this theorem basically says that if I look at an exterior angle of my triangle, so meaning this is the exterior angle of the triangle, this is on the inside. So a triangle is made out of the 3 interior angles, 1, 2, let's label them 3. And what we just learned recently was that angle 1, 2, and 3 added up is always going to be 180 degrees, no matter what size or what shape the triangle, or what size or whatever the triangle is. It's going to be the same shape as the triangle, right? But what we see here is something interesting. Basically, this is called the exterior angles theorem. And this is saying that the angles on the outside, the exterior angle, is going to be the sum of the two angles that's opposite from the supplementary angle of what we're looking at. Basically, what this is saying is like this angle, this yellow angle, would be the sum of angles 1 and 2. So angles 1 plus angles 2 is what this angle measure would be. All right. And if you wanted to test that out by like drawing a triangle on a piece of paper, cutting it out, cutting these out, and then, you know, piecing them together on this part here, you could, right? And it would be the same. It would be these two angles added together making this. And we can kind of conclude this after knowing our previous angle. We know that angles 1, 2, and 3 added up has to be 180. So if angle 3 is right here, the remaining parts would be angle 1 and angle 2, right? And that would add up to be 180 degrees all around when all of them are added together. So I think after seeing the visual from the last video there, I think this will make more sense here. So let's go back to my study guide. So over here, basically we can use this information to help us find missing parts. So for example, number 1, if we want to find this angle measurement, we could just do 50 plus 65, right? Angle 1 equals 50 plus 65 degrees, and then angle 1 would be 115 degrees. Over here, we're looking for both angle 1 and 2. So to find angle 1, that would just be 35 plus 25. And angle 1 would equal 60 degrees. Now, if we're looking for this other part, angle 2, well, aren't angle 1 and angle 2 supplementary? They're a linear pair. So I know if I found angle 1, I can find angle 2. So angle 2 is basically 180 minus 60 equals angle 2. And so that would be 120 degrees. And you can double check this by adding everything back in. So 25 plus 35 plus 120 should be 180, because I know the sum of all the interior angles should be 180. All right, looking here, we've got, let's see, we've got this angle 3 here, and we're looking for angle 1 and looking for angle 2. So let's think about this. If I know that these are parallel, these are also parallel, this is 60 degrees, this is 60 degrees, how many degrees do you think angle M would be? Probably 60 degrees, right? So then thinking through this, if I've got 2 parallel lines and then a transversal right here, and then maybe another cutting through here. If this is 60 degrees, what do you think this angle would be? Probably 60 degrees, right? This is what we call alternate interior angles. We just learned that last chapter. So 60 right here, 60 right here, alternate interior angles. So angle 2, we don't even have to work it out, it should be 60 degrees. Now looking at angle 1, we need to find angle 1, right? So we've got this transversal, these 2 parallel lines. It's a little bit tricky to look at, but I'm going to do it in green. So I've got these 2 parallel lines, and then this transversal. So that tells us from what we know here, this is 60 degrees. So I'm going to label this 60 degrees. That's 60 degrees here. Then this is an alternate interior angle using the green lines. That would also be 60 degrees. So angle 1 is also 60 degrees. All right, now that we know 1 and 2, we know that the sum of angle 1 and 2 equals angle 3. So angle 1 plus angle 2 is what angle 3 is. So angle 3 is just 60 plus 60, which is 120. Okay, let's take a look at number 4. We've got a few triangles going on. So I think the best way to go about it is to find the triangle that has the most information first. So this triangle, VTU, has the most information. We know that these 2 angles are 35 and 36. Well, the third angle, we know that all angles inside a triangle add up to be 180. That means if I know angle 1, or sorry, if I don't know angle 1, I can just add angle 1 plus 35 plus 36, and that should equal 180, and that's the triangle angle sum theorem that we learned just right before this. And so 180 minus 35 minus 36, what would that be? 109. So angle 1 is 109 degrees. Now, if this is 109 degrees, let's take a look at if we know anything else that can help us. So let me use red here maybe. Notice that angle 1 and 3 together make this straight line. So if I know that angle 1 is 109, how would I be able to find angle 3? Well, I know these are supplementary, they're a linear pair, so I could do 180 minus 109. That equals angle 3. So what's 180 minus 109? 71 degrees. 71 degrees is angle 3 here. Okay, now that I know angle 3, what do I see over here? I'm gonna use a blue color, maybe purple actually. So if this is 79 or 71 degrees, what would this angle be? Well, what's the relationship between these two angles here? They are vertical angles, which means they're congruent. So if they're congruent, this angle would be 71 degrees, and I can now use that two angles plus angle 2 equals 180. So angle 2 plus 80 plus 71 equals 180. Now I can subtract from 180. 180 minus 71 minus 80 is 29. So angle 2 equals 29 degrees. And that's my answer. I didn't even use the exterior angles theorem, which I could have. I probably should have. I probably should have found the exterior angle by basically doing 35 plus 36 equals this exterior angle here, which is 71. So that even works out for me too, but I didn't even have to for this one. All right, so let's take a look at these last two problems. We know, this time we know the exterior angle is 145. So if we think through the exterior angles, we know that angle A plus angle B should equal ACD, right? So I'm gonna say angle A plus angle B equals angle ACD, which is the exterior angle. Now, if I know this truth, I can literally just replace the information that is replace it with what's given to me. So angle A is 95 degrees. I would put that in place of angle A. Angle B is 2x, so I'm going to replace angle B with 2x. And then ACD is 145. So then I would just replace that and work this out. So minus 95 minus 95. I have 2x here. And I think 145 minus 95 is 50. 50 divided by 2 is 25. Oh, this is 50. And then divide by 2. X equals 25. That's my answer there. So X is 25. Then what they said is find the measure of ABC. So read your directions carefully. ABC is right here. We're looking for this measurement, which means we have to plug X back in. 2x, 2 times 25 is 50 degrees, so this is 50 degrees. All right, this is saying find angle F. So here's the thing. Angle E plus angle F equals 58 degrees, or angle EGH, right? Now I know E and F are x degrees. So x plus x is really just 2x. So I'm going to simplify that, 2x. Now divide by 2 on both sides. So my answer is 19. And so angle F is 19 degrees. Sorry, 29 degrees. 29 degrees. And that's it.